Okay students, Ayubowan, welcome you all for today's video. අද පොඩ්ඩක් හදිසියෙම මේ වීඩියෝ කරන්න හිතුනේ හෙට ගොඩක් අයට තියෙනවා එක්සෑම් එකක් practical chemistry level 4. ඉතින් මේකට මම ලොකු දෙයක් කරන්නේ නැහැ. මම නිකන් ඔයාලට practical day school වල explain කරපු practicals ටික මම නැවත පොඩි මතක් කිරීමක් විතරයි කරන්නේ. Today I am going to remind you about the practicals done on the practical sessions in your level 4 PS1 practicals. So this is quick revision. I am not going to talk about experiment in detail. However, by experiment and experiment I will explain the special points, and also I have to tell that I am not going to do the theory. Theory is in your book. theory එක ඔයාලා දන්නවා, ඔයාලගේ පොතේ තියෙනවා theory එක. මම theory එක ගැන මුකුත් කියන්නේ නැහැ. මම නිකන් experiment එක නිකන් discuss කරනවා පමණයි. හරි. Experiment number 1, iodination of I am using copy of books, kinetics of iodination of acetone. acetone වල iodination reaction එක තමයි කතා කරන්නේ. Iodination reaction of acetone. What was the basic reaction? The net reaction was, this is acetone, CH3 CO CH3, this is your acetone, and this will be react with added I3 minus, and we add acid as a catalyst, and final product will be CH3 CO CH2I plus 2I minus plus H plus. This is the overall reaction. This is the overall reaction of this iodination reaction. However, I am going to discuss the procedure and important steps. Okay. This is the overall reaction. So, as the procedure, we place 5 ml acetone, 10 ml HCl, 75 ml distilled water. So, there are two groups of chemicals. In first group, we have to add 5 ml acetone, acetone 5 ml, and 10 ml HCl, and 75 ml distilled water. We have to take care about the decimal places. Here they mention 5.00. Here 10.00 HCl and 75.00 ml distilled water. So here acetone is known as solution B, HCl is solution C, and distilled water, and another vessel we will add iodine solution. We have to add 10.00 iodine. So what is the procedure? Place 5 ml acetone, 10 ml HCl, and 75 ml distilled water in appropriate vessel. Add 10 ml of iodine solution A. This is solution A, into the above mixture. This we have to mix these everything. This set 1 chemicals we have to mix. So we have to mix them in a stoppered bottle, because we are dealing with iodine. They will evaporate, so we have to keep them inside a stoppered bottle. So stoppered bottle's neck is very narrow and it has a lid. So I2 vaporization will be minimized during this process. However, we mix these three things, chemicals, in this stoppered bottle, and we will add, after mixing, we will add here mixed chemicals, our mixture, and we will add I3 minus 10.00 ml into this mixture. So this is A. To follow the variation in concentration of iodine in the reaction mixture as a function of time, extract 10 ml of reaction mixture after 5 minutes, commencement of the reaction, and transfer it into 10 ml sodium bicarbonate solution. Hurry. First thing, we have to mix these three things. However, before mixing, we have to get necessary precautions, because we have to conduct this experiment under 20 degrees Celsius. They mention the temperature as 20 Celsius. Very important thing they mention finally. Okay, and here when explaining, I mention very important things. First thing is volumes. They mention 2 decimal points. 2 decimal points. 2 decimal points mean the accuracy should be very high. නිරවද්‍යතාව very ගොඩක් ඉහළ වෙන්න ඕන. If they mention just 5 ml, we can use measuring cylinder or any beaker. However, here they mention 2 decimal points. 2 decimal points meaning we have to use pipette, burette. Especially in pipettes, we have to mention the volume of pipette. We have to mention the volume of pipette. We can't just say pipette. If you said just pipette, you will not get any marks. You have to mention the particular volume. Or if you don't mention the volume, you can say the graduated pipette. Pipette or graduated pipette. These are the important things. Pipette, burette or graduated pipette. So if they have given 2 decimal points, you have to mention one of these three instruments, glasswares. That's the first thing. And here, if they mention Celsius 20 degrees or lower, we know the room temperature will be very higher than it may be 27, 28, 30 it will be vary. However, here they mention we have to keep our reaction in 20 Celsius. So if they mention this temperature, we have to maintain the temperature. How? We can, before mixing them, we have to maintain water bath but we have to add ice cubes. We have to add ice cubes into a water bath and we have to check the temperature. We have to use a thermometer. Whether the water bath come to 20 degrees Celsius. So we have to check the temperature. So what is the first thing? We have to make a water bath and we will add some ice cubes and we will check the temperature. If the water bath is coming to 20 Celsius, now we can add our separate solutions A, B, C, D likewise distilled water, and separately these solutions we have to keep in this water bath, and we have to check whether they are in the correct temperature, 20 degrees. So we have to use separate thermometers, and we will add thermometers into these solutions separately, and we will check the temperature whether it is 20 degrees or not. Okay, so first thing we have to maintain the temperature, and we will keep our reactants in that water bath, and we have to check the temperature. So we have to sterile well. We have to mix the water bath as well as the solutions also. We have to shake them. So we have to stir. On other words, we will be using a glass rod, and we will mix the water bath very well to obtain a uniform temperature, homogeneous or uniform temperature. After water bath coming to that 20 degrees, we will not add ice further, and we will mix our separate solutions also to get homogeneous solution with unique temperature. After these solutions also getting 20 degrees, after that we can mix them together in the water bath. Now our solutions are also in 20 degrees. So now after mixing, the solution will be 20 degrees. So before mixing, every reactant should come to this 20 Celsius. After they come in 20 Celsius, we can mix them. Before they are in 20 degrees, we can't mix. Okay, this is first thing, very important thing. They will ask you about this. Okay. Now this reactant mixture is in 20 degrees. So the iodine solution, this also should in the water bath. Before mixing, it also should be in the water bath with 20 degrees. After that we can start the reaction. Okay, these are the basic things you have to remember. Okay, here this 5 ml of acetone, we can use the here 5 ml burette, 5 ml acetone, and 10 ml HCl, and 75 ml distilled water. Here in our lab we have 5 ml pipettes. So we can use 5 ml pipette to add this acetone solution, and we have 10 ml pipettes also. We can use 10 ml pipette. However, to measure the distilled water 75 ml, we can use a burette. We have 50 ml burettes. We can get 1.5 of this burette to get 75 ml. Okay. After measuring them, we have to add 10.00 ml iodine solution. So to measure this thing also, we have to use higher accurate glassware or measuring device. We use pipette, 10 ml pipette. Okay. When we go further in our experiment, what should we do? So here we will add this I3 minus or iodine solution into this reaction mixture, and we have to use a stopwatch. When we adding this iodine, we have to switch on the stopwatch. We have to start the stopwatch. When should we start? That's the thing. So this is your reaction mixture. Actually not a reaction mixture, this is not reacting now. After adding iodine it will react. Here iodine in your 10 ml pipette. Here your iodine. Okay, here 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and this may be 10. However, this is 10 ml. When should we start the stopwatch? Initially if we switch on when the first drop is dropping into the reaction mixture, if we switch off the switch on the stopwatch, there may be an error. There is a big error. When we switch on our stopwatch, when we adding first drop, in first drop there is a great error. What is that? If we switch on our stopwatch when we adding first drop, what will be the error? Here this reactant is very high in this stopwatch bottle. Reaction mixture is it contains very higher concentration, and in contrast to that, this first drop contains small amount of iodine. So very small amount of iodine. Its concentration is its amount is very low compared to this second reactant. This is first reactant iodine and this mixture is the second reactant. When they mixing, the reaction will start. However, with respect to this reaction mixture, it contains very higher amount of reactant too. However, in a drop of iodine, amount of iodine is very low. So to react this small amount of iodine, there may be a massive amount of second reactant. So reaction rate will be very high at the beginning. When we add first drop, reaction rate is very high. On the other hand, just consider this reaction mixture is here. What about if we switch on our stopwatch after we adding final drop? Now everything is drained into this mixture. Now our both reactants are here, iodine and I3 minus and acetone. Both are here. We added everything and we add final drop. When we adding final drop, we start the stopwatch. What is the error? Is it correct? No, because now every reactants we added, every iodine full volume of iodine we added, now we add last drop. So now reaction rate will be very low. Initially it is very high when we add first drop. When we adding last drop, it will be very low. It also error. So what should we do? To reduce this error, we have to take the middle value or middle volume. So we have to switch on the stopwatch when we after adding 5 ml. We not getting first drop or we not getting second last drop. We will start our stopwatch when we adding 5 ml. After adding 5 ml, now half of the solution will be in the solution mixture and half will be in the pipette. At that time we will switch on our stopwatch. This thing we will call draining time error. To reduce the draining time error, we will do this thing. So before start the reaction, we have to measure the draining time. Okay, what is the meaning of draining time? This is your pipette. here your 10 ml. Before starting the reaction, we will get 10 ml of distilled water into this pipette, and we have to keep it in vertical position. We will keep our finger here. We will control this pipette by using our finger in this situation, or we can use a pipette filler. One of these you have to use throughout the experiment. Okay, here I will use my finger. So how can we measure the draining time? We will take a stopwatch, and here 10 ml, this is the mark, 10 ml mark. I will get out my finger from the edge of this pipette, and I will start the stopwatch. To drain 10 ml, there will be a certain time. We will consider that time as TD, draining time. Draining time. After measuring this draining time, just consider it will be a 10 seconds. Maybe 10 seconds. Draining time will be 10 seconds. Okay. If the draining time is 10 seconds, we consider 5 seconds. We will add our we will start our stopwatch after 5 seconds. Full draining time is 10 seconds. We will consider 5 seconds. Okay, that's the draining time thing. Okay, what should we do after this? Now, after mixing, this reaction will happen. CH3CO CH3. Iodine will replace one hydrogen from this CH3 group, and this will be the product. Okay, after 5 seconds, after 5 minutes, what should we do? We have to extract 10 ml of this reaction mixture, and we will add into a particular vessel. What is that? Conical flask which containing sodium bicarbonate. Why is that? අපි මොකද කරන්නේ? අපි මේකෙන් මේ ඔක්කොම මික්ස් කරලා විනාඩි 5කින් 5 minutes interval වලදී time here 5 minutes. After 5 minutes we will get 10 ml of this reaction mixture, and we will add it into a sodium bicarbonate solution. Why is that? That sodium bicarbonate solution is which is 10 ml. 10 ml. Look at the decimal points. 10 ml, just 10 ml. It is the D. So that solution is known as D. Okay. What will happen here? Why we add 10 ml into this conical flask? What is the reason? What is the reason? Because to proceed or to happen this reaction, we add HCl, 10 ml of HCl. That means H plus we needed as a catalyst. As a catalyst, we added H plus. Without this catalyst, reaction will not happen. අපි මුලදීම උත්ප්‍රේරකයක් දැම්මා HCl තිබ්බොත් විතරයි මේ iodination reaction එක වෙන්නේ. ඉතින් අපිට ඕන to stop the reaction. We want to stop the reaction, and we will measure the amount of iodine remaining in the solution. අපි මොකද්ද මේකදී අත්‍තරම කරන්නේ? විනාඩි 5කට පස්සේ මේ reaction mix එකෙන් කොටසක් ගන්නවා 10 ml අර ගන්නවා. ඒක ලියවලා එයා දානවා මේ sodium bicarbonate solution එකට. අපිට බලන්න ඕනේ මේ විනාඩි 5ේදී solution එකේ ඉතුරු වෙලා ඉන්න iodine කොච්චරක් ඉන්නවද කියලා. We have to measure the amount of iodine remaining in this solution. So to stop, we have to stop the reaction at 5 minutes. We have just like we are getting a photograph. Okay, so we have to stop the reaction. So we will to stop the reaction, we will add this base. Sodium bicarbonate is a base. it will react with H plus. Okay, it will produce carbonic acid. However, without this catalyst H plus, reaction will not happen, so reaction will stop. Reaction එක නතර වෙනවා. එහෙනම් තමයි අපි sodium bicarbonate තියෙන එකට දාන්නේ. Okay, after we added reaction mixture 10 ml. Extract 10 ml. So we extracted 10 ml. So we extract 10 ml, 10.00 ml. So here also we have to use the pipette, 10 ml pipette. So here also draining time is very important, because imagine we start our experiment in just imagine 0.00 time. Time is 0.00. Okay. Now we have to stop the reaction at 5 minutes. So when t equal 5:00, we have to stop the reaction. So before it passed 5 minutes, we have to insert this pipette, and we will suck 10 ml of reaction mixture, and we will start adding this reaction mixture into the solution. We will start around 4.55 seconds, and it will stop at 5.05. We are doing that because we have to get rid of the draining time error. So after draining everything into this solution, time will be 5.05. It seems we spent 5 seconds, adequate 5 seconds. However, it is not an error, because we deduct our draining time error. It is 5 seconds. We add our solution into this reaction mixture, iodine solution into the reaction mixture. After 5 seconds, we start the calculating time after 5 seconds. So when we doing this thing, we will start draining of this reaction mixture into the sodium bicarbonate solution. We start at 4.55, and if the draining time is 10 seconds, consider draining time is 10 seconds. If the draining time is 10 seconds, we will start our draining process in 4.55. So it will end up in 5.05. So this 5 seconds mean the error. Okay. Okay, that's the thing, draining point error. Now reaction is stopped. Now we will titrate this solution by using we will use the sodium carbonate solution. Here your reaction mixture. We use sodium thiosulfate solution. Okay, we will start the titration. What will happen? This sodium thiosulfate will react with remaining iodine in the solution. So plus 3I minus. Here the stoichiometry of will be here 2:1. Okay. The stoichiometry is 2:1. So just like this, you have to do this experiment after 10 minutes. Initially you did 5 minutes and 10 minutes and 15 minutes, 20 minutes likewise. You have to do after 5 minutes interval the same procedure. Think about this draining time and you will do the titration with sodium thiosulfate solution. From this titration you will know they will be given the concentration of sodium thiosulfate. By using that you can calculate the amount of iodine in this remaining in this mixture after 5 minutes. Okay, you will get the iodine concentration. Likewise, after 10, 5, 15, 20, 25 likewise you can calculate the remaining iodine concentration. What will happen? You know, initially at the beginning of this experiment, iodine concentration will be very high at the beginning because both reactants are in large amount. But with the time, the reaction will happen and iodine will decrease. කාලෙත් එක්ක මොකද වෙන්නේ? iodine සහ acetone react කරනවානේ. මුලදිම දෙන්නම වැඩිපුර ඉන්න හින්දා reaction එක පටන් ගත්තා විතරක් නිසා iodine වැඩිපුර ඉන්නවා. But after time කාලය ගත වෙනකොට iodine නිතරම react කරලා iodine ඉවර වෙනවා. With the time iodine concentration will be decreased. So we will plot a graph with concentration and time. You will be get this type of graph. මේ වගේ graph එකක් ඔයාලට එයි. ඒකෙන් මොකද්ද කියවෙන්නේ? Chemical kinetics, according to chemical kinetics, 0th order. You will be get this type of graph. That means the order of iodine with respect to iodine, the order of the reaction will be 0. So that's the conclusion. I am not going to talk about further calculation because it is unethical. මේක ethical නැහැ. මම තවදුරටත් ඉස්සරහට මේක කරොත් මම දැනට මේ ටික විතරයි මම කියන්නේ. ඔච්චර තමයි වල කරන්න ඕන. After doing this experiment, you have to replace the acetone volume as 10. So after doing this first experiment, you have to repeat the experiment with 10 ml of acetone. Initially you used 5 ml of acetone. After doing this, you have to take 10 ml of acetone and you have to repeat this experiment. Okay. So important things I have to mention here. Now in this experiment, we have to use very clean glasswares. So that is very important. In every chemistry experiment, you have to use very clean glasswares. There are a few methods to clean. What is that? First thing, you have to wash. Wash with tap water. First thing, I will erase these things now. First thing we have to use wash with tap water. If we use tap water, we are calling that washing. Next thing, we have to use distilled water. When we using distilled water, we are not saying washing, we have to mention the rinsing. Rinsing with distilled water. Here tap water, wash with tap water and rinsing with distilled water. After that, we have to rinse this glasswares with relevant solution. But not every glassware. When we are using very special things, when we using burette and pipettes, these things we have to rinse with the relevant solution. What we are going to add to that solution, what we are going to measure from this glasswares, we have to rinse this glasswares with that solution. because if we are not washing or if we are not rinsing, there may be a error, because before measuring we rinse this glassware with distilled water. So if there are distilled water particles inside these glasswares, the concentration of these solutions what we are going to measure will be decreased because of dilution effect. Because initially we rinse with these instrument with distilled water, there may be some water particles inside the glassware, and when we are measuring some solution from this glasswares, they may be diluted because of this remaining distilled water. Because of that, before measuring or before adding any solvent, we have to rinse this glassware from particular solvent, that relevant solvent. We have to add small amount of that solution or solvent. We have to rinse it with, and after that we can measure. However, all the other glasswares like beakers and measuring cylinders, conical flask, likewise these are, we have to wash, rinse with distilled water, and we have to dry. There are two methods of drying. First one is oven drying method. Second one, we can desiccate. And third one, actually three methods: oven drying, desiccation, or we can use acetone. We will add small amount of acetone, and acetone will evaporate very quickly with water particles. So we will add acetone, or we can desiccate, or we can use oven drying method also to dry. After drying, we can use these particular glasswares. So these are the important things you have to remember. Okay. Now there are some other things also. We have to check about the we have to care about the draining time also. So we have to use a ice bath or water bath which contain ice to maintain 20 degrees Celsius, because this we are talking about the kinetic. අපි චාලක රසායන ගැන කතා කරන්නේ kinetic, this K reaction, this K values or rate constants will depend on the temperature නේ. Rate constant උෂ්ණත්වය මත රඳා පවතින හින්දා we have to maintain the temperature at 20 degrees. Okay, we have to label every glassware, we have to label, otherwise everything will be missed. So we have to label everything. And the other thing, when we are selecting glasswares or measuring devices, if they mention in 2 decimal points, we have to use burette or pipette. We can't say just pipette. We have to mention the volume of that pipette, 10 ml pipette, or we can say graduated pipette. You can use these two names, but you can't use just pipette. You will not get any marks for this just pipette name. You have to mention the volume, or we have to use the graduated pipette, that conditions. Okay. So if they give 5 ml, 10 ml, 25 ml, 20 ml likewise, this type of measurement can use by particular 5 ml, 10 ml, 20 or 25 ml pipettes. However, larger volumes, likewise 50, 75, this type of volumes we can measure by using a burette. Okay. So we have to swirl, we have to the reaction mixture, and every time these solutions we have to swirl very well, because we need the homogeneous solution. Okay. On the other hand, we have to take care about the when we are using the burette, we have to think about the meniscus. We have to care about the meniscus. When we are balancing meniscus, we have to take care about if there are trapped air bubbles. We have to check about the tap. Near this tap region there may be air bubbles. So before we start titration, we have to check whether the volume is correct, the meniscus is correct, tap is correct. Everything we have to check before start this experiment. We have to use a white tile. So what will be the experiment's observation? What will we using as the indicator of this experiment? Titration. When we use sodium thiosulfate, iodine, what will be the what will be our indicator? Should we add indicator? What will be that? What will be that? So we use starch as the indicator. Initially this solution reaction mixture will contain high amount of iodine. So initially we do not add starch as the indicator. So we allow these solutions come to pale yellow color. After becoming pale yellow, we can add starch, because if we add starch initially, what will happen? The starch will form a strong complex with remaining iodine. It will be not dissociate, so we can't get any observation, or we can't do the dissociation, so it will be an error. So we have to allow the solution turn into a pale yellow color. After it's turning into pale yellow color, we will add starch. After adding starch, solution will be blue color, and we will do the titration until the solution is colorless, okay, or white color. That's the final thing. After that, we will stop the titration and we will read the volume of sodium thiosulfate. After that, according to their stoichiometry, we can calculate we know the concentration of sodium thiosulfate and we know the volume, and we will calculate the amount of sodium thiosulfate. By using that amount of sodium thiosulfate, according to their stoichiometry, you know the amount of iodine. How? The stoichiometry is 2:1. 2 mole of sodium thiosulfate react with 1 ml of iodine. So half of sodium thiosulfate concentration is equal to iodine. You know the total volume of this reaction mixture, and after that you can calculate the concentration of iodine. So after 5 minutes, 10 minutes, 15 minutes and 20 minutes likewise, you can get concentration of the iodine. You can plot a graph with iodine concentration with time. You will get the particular graph with zeroth order reaction. So that's the thing, you can do that. So that's the summary of experiment number 1. We will move to second experiment.